Welcome back. In this section, we'll meet the dictionary, a data structure that lets you look something up by name instead of by number. It's one of Python's most useful tools, and once it clicks, you'll reach for it again and again. Here's what you'll be able to do by the end. Explain what a dictionary is in terms of keys and values, and how it differs from a list. Create dictionaries, read and change them, add and remove pairs, and travel through them in a loop. And use dictionaries the way real programs do, counting things, and standing in for simple objects. Let's start with the idea. Think of a real dictionary. You have a word and you look up its definition. Swap word for key and definition for value, and you've got the computing version. A dictionary is a data structure where, if you have a key, you can fetch its value. Each key brings up exactly one value, just like a variable name brings up its value. So you can think of a dictionary as a bundle of named variables you can carry around together, and even return from a function all at once. How is this different from a list? A list also holds many values, but you reach them by a number, the index. Give me the 7th item. If you stored students in a list and wanted David's grades, you'd have to walk the whole list hunting for David. With a dictionary, David is the key, and his grades pop straight out. Keys are like indices that don't have to be numbers. That means they can carry real meaning, a name, a date, a product. Let's watch a lookup. Picture the dictionary as a column of boxes. On the left sits each key, on the right the value it points to. When we ask for the key sprockets, an arrow runs across and the matching value 5 lights up. Ask for widgets and 11 lights up instead. No counting, no scanning. The key takes us straight to its value in a single hop. That's the whole appeal. In Python, dictionaries are wonderfully direct. We use curly braces, and inside, each pair is written as key:value, separated by commas. Here's an inventory: sprockets 5, widgets 11, cogs 3, gizmos 15. To read or change a value, we use square brackets with the key inside, just like a list, but with a name instead of a number. One thing to know: Python doesn't promise to keep the pairs in the order you typed them. The keys are what matter, not their position. Adding to a dictionary is delightfully simple. There's no append method. You just assign a value to a new key, exactly as you'd create a new variable. Say my dictionary, gadgets in brackets, equals 1, and the key gadgets springs into being. Use a key that already exists, and you simply overwrite its value. To remove a pair, use the del keyword. And before you reach for a key, you can check whether it's there with the in keyword, which avoids an error if the key is missing. Often we want to visit every pair. Python gives us 3 handy views for that. Loop over values to see just the values. Loop over keys to get the names, and looping over the dictionary itself does the same, defaulting to keys. Best of all, loop over items, and each turn hands you the key and the value together. 3 ways to travel, depending on what you need. Here's a classic use: counting words in a piece of text. We tidy the text, lower its case and split it into a list of words. Then for each word we check the dictionary. If the word is new, we add it with a count of 1. If we've seen it before, we add 1 to its count. When the loop finishes, every word is a key, and every value is how many times it appeared. A dictionary makes this almost effortless. Let's trace it. We sweep through the words one at a time. The first time we meet a word, a new box appears with a count of 1. Each later citing bumps that words count up by 1. Watch the numbers climb as repeats roll in. By the end, the dictionary holds every distinct word with its tally. The same trick powers everything from spelt checkers to search engines. Dictionaries can also stand in for simple objects. Picture an address book where each person has an address, a phone number, and an email. Store each person as a small dictionary, with keys like phone and email. Now you fetch the phone number by name, by the key phone, instead of remembering it sits at index 1. And if every person's dictionary uses the same keys, you can loop over everyone and pull out each one's email by name. That's a low-cost taste of object-oriented programming, which is coming up next. Let's recap. A dictionary maps keys to values, give it a key, get a value in one hop, no scanning. Build them with braces and key::value pairs. Read and change with square brackets. Add by assigning a new key, remove with del and check within. Travel with values, keys, or items, and lean on dictionaries for counting and for grouping a thing's details under one name. This lesson is based on Section 4.5 of Introduction to Computing by David Joyner, used with permission. The concepts are taught in original words, and every diagram was recreated as an original animation. I'll see you in the next section.